Hello, trust you are doing fantastic. So in this video, I'm going to be introducing a new course. I've got a lot of requests to do this video on digital logic electronics. Trust me, you're going to enjoy this video. And to remind you, I have a practical class alongside with this course. It's titled Arduino. You're going to find it in the playlist under this channel. Alright, so I'm going to be teaching you how to program electronics using Arduino. So without wasting much of our time, let's go straight into today's topic. Now you may be wondering, what is digital logic electronics? I need to let you know that logic is nothing but a fundamental concept in digital electronics. Logic is actually the building blocks of digital electronic circuit, and it performs basic logical operations. Now, digital electronics is nothing but a field of electronic science that deals with the design, implementation, and application of digital circuits. Let's go straight into the topics that we're going to be covering in this course. Now, we'll talk about the number systems and binary arithmetic, logic, gate and Boolean algebra, combinational circuit, sequential circuit, logic family, semiconductor memories, AD and DA converters, and finally we'll be talking about the microprocessor. Now, these broad topics are broken down into subtopics. So in each of these topics, we're going to be talking about sub areas. For example, the number system will contain topics like decimal number system, binary number system, octal number system, all the way down to the tools complement representation. In the other subtopic, which is the binary arithmetic, we'll talk about the addition and subtraction of binary numbers, overflow and carry in binary arithmetics. We'll talk about multiplication and division of binary numbers all the way down to the bitwise operations. Now, number system and binary arithmetic are fundamental concepts in digital electronics and computer system. Now, the binary system is the most commonly used number system in digital electronics, as digital signals can only have two values, and which is 0 and 1. So that is why we call it binary. Okay, so we're going to be talking about the different conversions, converting number from one binary system, from one base system to another, binary to octal to decimal, and all of that. So we'll talk about the logic gate and Boolean operation as well. Now, the logic gate, like I said previously, and the Boolean algebra, they are fundamental concept of digital electronics and computer systems. So the subtopic we're going to be covering under this topic are the logic gate and the Boolean algebra. So under the logic gate, we'll talk about the AND gate, the OR gate, the NOT gate, all the way down to the implementation of logic gates using transistors and other digital circuits. And on the other hand, where we'll talk about the Boolean algebra, we'll cover topics like the basic concept of Boolean algebra, Boolean functions, and truth table. And we'll also introduce an important law, which is the Morgan's law. I will also talk about the simplification of Boolean expressions. We'll also talk about the canonical forms, which is the SOP and the POP. So the next topic we'll also treat is the combinational circuit. And under combinational circuit, we have two sub areas where we'll talk about the design of combinational circuit as well as the analysis of combinational circuit. So these are the things we're going to be talking about under this two subtopics. And then I would like to bring to your mind or to your knowledge that combinational circuits are a type of digital circuit that output a function of current input. Now, the output of a combinational circuit depends only on the current input and not on previous input or the state of the circuit. So this is the whole concept about combinational circuit. So we're going to use Boolean algebra and logic gate to design combinational circuit. Now, you cannot jump into this topic you need to first and foremost go through the first topic, which is the number system and the binary arithmetic. You also need to go through the logic gate and the Boolean algebra before you can understand this course in depth, because we're going to be building on those two topics in order for we to build a combinational circuit. So that is the whole idea. So trust me, this course is going to be loaded. It's going to be so rich. Now the next topic we're going to be treating is the sequential circuit, and this sequential circuit is divided into two major subtopics, which is the design of sequential circuit and also the analysis of sequential circuit. They are widely used in digital systems, from simple input-output function to complex algorithm and data processing. Now, understanding the design and analysis of combinational circuit is important in the implementation of digital system and in ensuring the correct and efficient operation. So it means that in sequential circuit, you also need to go through the combinational circuit, because that is where we're going to be building from. So it means that every topic in this course is building upon the previous topic. So you cannot understand the sequential circuit if you do not understand the combinational circuit. So these topics are built upon each other. So I'm going to encourage you to go through these topics from the very beginning and follow through to the very end. So the next topic we're going to be talking about is the logic families. But then I'd like to introduce to you a basic concept of the logic families. Now, these are a set of electronic logic gates and digital circuits that are based on specific technology and circuit design. Now, different logic families have different properties and specifications, such as power consumption, speed, noise margin, and voltage levels, which determine their suitability for different applications. Then the next topic I will take you through is the semiconductor memories. And under the semiconductor memories, we will be talking about the different type of semiconductor memories. Now, before I begin, you might be wondering, why semiconductor memories? Now, let me introduce the basic concept of what semiconductor memories are. They are nothing but electronic memory devices that use solid-state semiconductor technology for data storage. Now, they are widely used in digital systems for storing information and programs. So we'll be talking about the different type of semiconductor memory. Next, we'll talk about the AD and DA converter, which is the analog to digital converter and the digital to analog converter. They are very important components in digital electronics. The subtopics we're going to be covering under this interesting topic is the AD converter and the DA converters. Now we'll talk about the sampling rate and quantization error, the different type of AD converters. AD, we'll talk about the flash, successive approximation, sigma, delta, error correction technique, application of AD converters. And then on the DA converter aspect, we'll talk about the sampling rate and quantization error as well, the type of DA converters. We'll talk about the pulse width modulation, the delta, sigma. We'll also talk about the digital to analog conversion techniques, the output impedance and load requirements, linearity and accuracy, application of DA converters as well. And finally, we'll be talking about the microprocessor. And in the microprocessor, we'll be talking about different subtopics. Now, before I go into the subtopics, I would like to introduce to you the concept of microprocessor. Now, microprocessor is a compact and integrated device that contains the processing unit of a computer. It is responsible for executing instruction and performing arithmetic and logical operation. Now, these subtopics I will be talking about are architecture, instruction set architecture, which is the ISA, the clock speed and processing power, memory management, interrupts and exceptions, as well as power consumption. I want you to pay attention to the subsequent videos in this channel, because this course is going to be loaded, it's going to be full of content, and I can assure you that you're going to enjoy this course from the very beginning to the end. Don't forget to subscribe, and for you who have already subscribed, don't forget to click the notification bell, because when you do that, you're going to get notification each time I drop a new video as regards to this course. Alright then, enjoy this video. Bye.